Hello, I welcome you all to this wonderful lesson. So we've got this interesting question that I just want us to answer together. We see how we can go about these important questions. Straight away we dive into the question. The question is saying, the figure below shows an object of mass 0.7 kg resting on horizontal surface. So this is an horizontal surface where it is resting on. So this is what you are given. The question is saying, if the object is pulled to the left by a force of 6.0 newtons, to the right by a force of 2.5 newtons, and assuming that no other forces acts on the object, calculate the first question. We are taught to calculate the resultant force. The question that you might be having, what is resultant force? I guess some of you can be confused. How can I calculate this resultant force? What you need to understand, if two or more forces acts on an object, the simplification of all those forces is what we call the resultant force. This is what you are supposed to understand. So resultant force, this is the force that you get after simplifying all the forces that get to act on an object. So in this case, we've got this force that is pulling it this side. We've got this force that is pulling it this other side. So now, in this case, we are taught to find the resultant force. So what you need to understand, whenever you've got two forces that are going in different direction, in this case, for you to find the resultant force, you just need to do what? You just need to subtract the two. So what you are going to do, you're just going to say 6.0 newtons minus 2.5 newtons. What answer are you going to get? So you are going to say 6.0 minus 2.5. The answer we are getting is 3.5 newtons. So this is our what? Our answer. This is the resultant force. If we add another force, let's say you add another force going this side. So if it was 10 newtons, meaning these two are going in the same direction, you need to add them and subtract this one that is going in the opposite direction. So this is what you are supposed to do. Resultant force is all about simplifying all the forces that get to act on an object. So you simplify them. I guess we are getting the point. We now move on to the next question. The acceleration produced by the resultant force. So they're telling you to say, calculate now the acceleration that is produced by the what? By the resultant force. Where is the resultant force? Resultant force is here. This is where we have the resultant force. So acceleration, we are given the mass is there. So meaning that what we are going to do, we are just going to say that, okay, acceleration is equal to what? Force over mass. This is a particular formula. So there is no need of bringing in the formula, final velocity minus initial over time. There is no need of using this particular formula. So this is what you're going to do. What is your force? Force, resultant force. This is 3.5 over. What is the mass? Mass 0.7, 0.7. So this is newtons, this is kgs. So finally, acceleration is equal to what? What is your acceleration? 3.5 divide 0.7. What is your answer? 5. So you just say 5 meter per second squared. So meaning that this is your what? This is your answer. This is what you are supposed to do for you to answer this particular question. As simple as this. So this is, I guess, we are able to see this answer. This is what we are supposed to do. We now go to this other question. So you cannot use this one. You don't have the velocity, initial velocity, even the time. So there is no need of using this one. Explain why, in practice, the actual acceleration for the object may be lower than your answer, this answer that we've calculated. So what you need to do, the reason why the acceleration may be lower than the one that we've calculated in the actual sense is because of friction. You discover that the friction between the object and the surface it is moving on can significantly cause an effect on this, or it can do what? It can cause the acceleration to be reduced. So it can cause an effect on the object. This is what you need to understand. So we are talking about friction. So friction on the object and the surface it is moving on can cause the acceleration to change. Another thing, we talk of mass availability. So discover that the mass it is having and the fuel consumption by the object can cause a decrease in the what? Acceleration. You need to understand all these things so you can just get one and answer it that way. So this is how we are supposed to answer this question. Those of you that wants to start my online lessons, this is the time you have. You can call me on my number, which is 0971 066747 plus 260971 066747. This is my number. I'm here to help you get a distinction in an easy way. So don't forget to follow and subscribe to my YouTube channel.